Good morning. Thanks again for attending. My name's Matt Sump. I'm our Illinois and Iowa account manager. I'm here today with Alex Zuniga, one of our applications engineers, as well as Matt Cesny. So without further ado, give us a second here while I transfer the presenter over to Alex and we'll get started.
Good morning, everybody. As Matt said before, my name is Alex Zuniga, one of the applications engineers here. And we're going to go ahead and get started with this rollout. Starting with design and basic functionality of Mastercam 2025, and then move on to mill, 2D, then 3D, 5-axis, and then eventually getting into the turning, mill turn side of things. So without further ado, let's get started. First thing I'm going to talk about is the drafting entities on solid models in previous versions wouldn't update if you made changes to the solid. Well, that has changed now in 2025. So if I were to go into the solids page here and update this block, let's just say I make it a 6x6, and then I refresh it, the drafting node is now live. This was only available using wireframe entities that would update automatically, but now solids will do the same thing as well. For those of you that are doing drafting nodes quite a bit, in the past you would have to go to your configuration and then go into your dimension notes section and update all the way in styles, lettering, font, all of that, all of the above in here that you would want to make your notes look like as you were making your drafting sections. In 2025, we now have the ability to save and load those defaults. So we have this section here now where you can actually save anything you do within your drafting entity section here, whether you're doing horizontal, circular, angle type drafting notes. However you build it within these menus, you can just save it, or if you just want to reload the way you usually have it, if you did something different, you can simply click the upload default, and it'll pull that information from that configuration file. That's a little bit about drafting. I'm going to move on to our analyze deviation. In previous versions of Mastercam, there was no way to tell if, let's say, this surface here was not built, or you wanted to compare it to something that you did build differently. These are different plates of surfacing, but let's say you wanted to create a surface that was a complete sheet, like so. See how this is a single surface compared to the original surface. Well, we want to compare the two. This is a pretty obvious section here that it's, there is a deviation here. But now we have a new tool inside of the 2025 called Analyze Deviation. So under Analyze Deviation, we can check our surface to surface. We can click the original surfaces that we want to compare to. Let me go ahead and turn that off real quick. And then we can compare that to our newly created surface. And now you can see it kind of looks like a stress analysis, showing you blue and green and red where the two surfaces line up. You can create the UV point directions to have more or less of these dots and color coordinated amounts in here. So you can see what's blue versus green. In here, we could even turn off what we don't want to see. Let's say we know the green is going to be good, so we can hide those green areas right here. And then we can take a look at what is underneath and what is above. As you can see, your blue sections, this surface right here underneath, and then your red and yellow sections right here. It's a little bit hard to see. If I zoom out a little bit, you can see a little bit better that kind of stress-looking analysis there. And you can see the tolerances of how they are set up. X amount for blue, X amount for red, and green, and so on and so forth. So this is a good little tool here to work with when you're trying to create extra surfaces to make sure you're staying on top of what you're originally working with. When working with mesh models, in previous versions of Mastercam, if you were to edit a mesh model, the toolpath will go dirty, like any other surface or model editing, but the associativity of that surface would disappear within the toolpath. So now when you edit those surfaces within the mesh model, let's say I smooth an area out real quick. You can see the toolpath went dirty. But now when I regenerate it, the toolpath will go automatically in there. The surface of that mesh never got removed from the model geometry. So if you are using any kind of mesh entity to program with and you need to make a change to it, that entity will no longer disappear from your toolpath. When bringing in models from different softwares and drafting notes from different softwares, it could be difficult to tell what is associated to what drafting entity. Right? So these drafting entities were not created inside of Mastercam. These are three-dimensional drafting entities. Different profiling, flatness, dimensioning, all that stuff. But how do we know what is exactly associated to that area? You know, we could assume this hex right here is the entire profile they're talking about here, but we don't know for sure. So if I go to Analyze Entity, and I pick the note now, in 2025, you can actually see that associativity. If I go pick this little horizontal dimension, you can see the two faces associated to that note. And so on and so forth. So just a little fun trick if you're dealing with this kind of notation in your parts when you open them up, you get some better information. When copying a solid in Mastercam, you would always get the list here of every copy you make. Well, now in 2025, it'll show you what has been copied, and it'll repeat that copied section over and over. So if I go ahead and I copy this model, let's say I put it on level 4 here. In my Solids tab, you can see it's a copy of that copy right here. If I copy that copy, say I put that on level 5, it now says copy of the copy here. If I copy the original again, you will get a different notation. You can see a copy 2 of the original. So that's the difference between copying a copied model versus the original model. So a little bit of extra notation that's, you know, a little bit easier for your eyes to catch where your copies are versus your original. I know I do a lot of model prepping, so I do copy a lot of different models. So having these notations helps me keep track of things, not just within my levels. Some last little notes about the overall user interface in Mastercam is for those of you that are using Weeboo licenses, standalone Weeboo licensing, anyone that has maintenance after November 15th of 2023 will be getting this notation here. It'll pop up and tell you, do you want to renew the license? Look for the license update and check for it. So you'll start getting these pop-ups as your license maintenance agreement comes close to expiration. It'll re-update your licensing and go from there. This only works for standalone Weeboo users at the moment. So any networking HASP or regular HASP or network Weeboo does not work with this at the moment. And if you're ever in a call with us and you need some, we need to ask you information about your licensing, or if you need to send us an email with your license info, you can now find that really quickly simply by hovering over this little info icon right here. If I hover over that right here, you can see that I have a license number, which is a HASP type license. So that about does it for the design portion of our rollout here. I'm going to move on to our milling. Are there any questions so far on any of the design stuff? Just taking a little quick sanity check. All right, doesn't look like anything's popped up yet, so we'll go ahead and continue. Some of you have seen this part before if you've been in our classroom training, but I just wanted to go ahead and show you some of the new features with our verify using this part here. So you can see here on this particular part, when I programmed it, it's got all these straight edges on there. A lot easier to program and work with. So if I went to verify, and I compare this model to what I ran on the screen, you can see I broke these edges here using a chamfer mill. If I use my verify compare, a lot of times you get these yellow edges and marking here because it is not exactly in comparison to the model that I used to program. So we know to ignore that information considering we know we want to break the edge. Well, in 2025, the addition of using this master model section here that we've introduced in 2023, we can now use this section here to compare against. My master model does have the the defined edges in it, as you can see here. So when I verify this, I have that ability to choose to work off of the screen model or the master model. You can see here if I turn this off real quick and turn on my workpiece, here's my screen model and here's my master model with that chamfer. So if I play through this and I watch the compare again, you'll notice everything's in green. So little details like that you might have a finished model for with extra radii or chamfers that you didn't actually use to program with, you can still use the master model as your finished product to compare against. So that's a little, fun fact in there for 2025. Some of you have used 2024 already, and at this point we have been using in the linking parameters these little planes now, these graphical plane representations of where all your heights and depths are, and any hole making capability, right? So in 2025 this has now been introduced to every single toolpath in the mill suite here, your mill 2D and 3D side of things. So if I go into this dynamic mill, you can see now I have these graphical planes. And they're as interactive as the hole making ones in 2024. You can physically grab the plane and move it. You can type in a number here. Or you can utilize it just as you have been in the past. You type in your values here, or you can pick a point in here. If you do not like the plane, or you want to turn off a specific one, you can just turn off the specific one here, or you can turn them off all together right over here. So they will go back to not being there. I know when I'm teaching class, it's a little bit easier to show that off where the customer can see where the retracts and the feed planes are going to be at. It helps them understand when you're dealing with using these incremental absolute values. So I do like the graphical representation in there, personally. In 2025, whenever you're using a dynamic mill or an area roughing toolpath in the 2D suite, in your geometry page, when you're picking your chains, they are now color coded. As you can see, my machining region is green, my avoidance region is red. You can change these colors quickly by double clicking on that square there, and you can choose whatever color you want to associate that type of chaining to. But I can see really quickly from this model the green chain, which I've chained as my machining area. And the red area is where I'm trying to avoid, as you can see here. So I know if I got mixed up, oh, what did I chain correctly? Did I miss an air region or something like that? You can look for the colors now and it just will pop up right in front of you. In addition to that, in 2025, we now have the ability to use finish passes within the dynamic mill toolpath, as well as area mill toolpath as well. So for those of you that are roughing and finishing with the same tool, you can quickly clean up that wall pass in here with a finish. You also have your traditional lead in, lead out menu as well. Now you can see I have the finish pass turned on in here with a particular pass of a 10 thou spacing here. And you'll see this toolpath here has the section cut out here. It doesn't run through like this one does. This one has it turned off, so you can see it roughs the entirety of that section. The reason that's happening is because that particular tool doesn't fit in there if we're roughing out, leaving 10 thou on that wall to finish. And the checkbox that's taking care of that safety section is machine finish pass at final depth and minimize burial. So with our minimized burial here, if I turn that off and I redo this toolpath, you'll see the toolpath only roughs out to that area, but the finish runs through the slot. Not ideal if that is completely filled with material. So that minimized burial is going to help out with any sections that didn't get touched in the actual roughing process. So that's a little bit about the finish passes with the area roughing and the dynamic mill. Moving on to hole selection. In previous versions of Mastercam, we have the ability to pick based off of the solid edge here. We could also pick through the entity right here. But now the entity itself would only pick just this cylinder and work with that information in that cylinder. Now in 2025, it will pick up the entire feature within this feature here. This entire chamfer, the counterbore, the hole itself. So if I click on any one of these sections here, you can see that everything turns orange in that field. Oh, yes it does. I believe there is a section in there. I can go back and look at that real quick. Let me jump in here. Here it is right here, cutter comp, computer control, wear, reverse. So hopefully that answers your question right there. Alright, going back to this hole selection here. The hole data itself is now historically accurate in that feature. So no matter where I pick up on this hole, it will be able to see all of that information in there. So if I hit the green check mark, pick myself a drill, I can utilize this section here called hole segments. This was only live for models that had that history associated into it. A lot of times we're importing models from different softwares and there's no history really associated to it. But now with 2025, you can see the entirety of that feature, that history that it used to need in there. Right now it's only calculating its depth in top of stock based off of this one cylinder. But now I can come over here and say, hey, let's do the entirety of this section. So when I go to my linking parameters, it'll give me a warning, hey, you're about to change that information. Sure. Now all my depths are planned from there. I can turn on my tip comp, break through, no problem. So you can choose what part of the segment you want to deal with. So let's say the counterbore and the chamfer have been taken out. So we can say go from the flat all the way to the end of this cone here and go to my linking parameters, and now I have all that set there. So I can get in a little bit closer for my retract. The huge thing about this is if we have multiple styles of features, you can deal with them accordingly. So let's say I grab this guy here and then I grab this guy right here. These are two different depths, two different hole sizes. So when I go inside of this menu, in the hole segments, I have a drop-down menu with these two different features. Maybe one of them has the counterbore and one of them doesn't. So maybe from this one we'll just do from here to here, and on the other one we'll deal with the entirety of that section. So when I go to the linking parameters, those depths are set accordingly. So this beats having to make multiple drill operations to find different depths of different holes and different features based off of how the part has been made. Very interactive selection in that hole capability. Now, if we have a majority of holes in here, you can see there's more than one feature. How do I make that picking selection easier? Well, if I grab one of these features, like this guy, and I window select the entire model, it now seeds the entire section there for the exact same type of feature. You notice I didn't grab any of these. These may be the same diameters, but it's not the same lengths, so it didn't work with that. So you would have to grab that one individually if you want to work with it. I can show you this process again. You just pick one of them, and then you just window select, and it'll grab all of them. And of course, you can still reorder the sort the way you normally would. It does have a blanket window as well that will just grab everything. But that kind of goes a little wild, as you can see, trying to drill this guy here. Not ideal. So for those of you that like to use the wireframe mask on arc button, now we have that kind of mask on arc using the solid. Pretty convenient. I think for those of us that are dealing with a lot of models that do have these edges defined on them, they're not just the hole. This is going to be a really big game changer to make your depths set at ease. So yeah, we would have to look at the part file that you have in question, and we can help you put that together. It says here, I was having trouble boring a hole with multiple holes. It would select all diameters. Excuse me. Yeah, we'd have to see that. If you want to send us an email with that information, with that tool path and that file, we can definitely look into it and see what's going on and get in touch with you. Stick around after the webinar. I'll speak with you afterwards. Moving on to some thread mill stuff. In 2025, the thread milling got a little bit of a facelift and a few extra fun icons to work with. In our tool page, when you're working with a thread mill, we now have this checkbox here to engage the tool edge feed rate. Now when you turn this on, it doesn't change the actual feed rate that you programmed in here, but what it does is it changes and does the calculation based off of where you're actually contacting your point of the material to the diameter of the tool that's walking around, right? So if I had this hole that I'm going around and my programmed circle is right here, because my tool diameter is right here, this feed rate would be different than this feed rate right here. So just by turning on that checkbox, it will automatically change that information for you when you post out your G-code. It doesn't graphically change anything, just within your post. As you can see here, those of you that use Threadmill quite a bit, these pictures are updated as well, based off of what you're working on, whether you're dealing with a thread pitch, the start angle, all that information in here. As well as a little bit of extra information that's showing up down here. Some of it has been there, but not all of it. You can actually see your spindle direction and what kind of cut you're dealing with when you're following the particular direction you've selected to go. There's also a few new buttons in here for the lead in, lead out section. These standard lead in and out options you've dealt with since this inception of this toolpath, but now we have this gradual engagement option, which what it does is the tool will engage 80% into the material of where the full final depth needs to be, and then as it travels up half the pitch of a rotation, it will end up being 100% engaged. So that's what that gradual engagement works with. So if you want to engage 20% and gradually go up to 100% engagement through a half pitch rotation, and you just put 20 here. The entries also have these options in here to start the plunge move after the first move. So I have that toolpath right here where you can see the tool is moving first in this direction to turn on compensation and then going down to take the cut. First move there and then cut out. So that's for when you're dealing with small holes that compensation is hard to get into, to turn on while you're in that area. You can turn it on above the part and turn it off above the part as well. You can turn on that retract before last move. So that's new within the Threadmill toolpaths. Moving on to some multi-axis stuff. The safety zone in Mastercam 2024 and previous versions was available. There was not, much of a difference in there. It hasn't been changed a huge amount, just with a couple options. But you can see in this particular toolpath, I have my safety zone turned on. I'll show you here. To follow this mesh wrap that's working around that part. When I backplot this, you can see the tool is tilting around, moving around, and then you can see right here when it's going to transfer to the other side to cut. It basically goes completely upside down, wrecks through the part, goes over, and then it does those drills. So it's respecting the boundary here on the linearization, but obviously we can't flip the entire table. This is my top spindle view here. So I literally flip this thing 180 underneath on the tilt. Not possible. So in 25, we added a couple little buttons in here to help alleviate that issue from happening in any safety zone capability. We added some linear tolerances, max angle steps, and blending and smoothing distances. These areas will help show where the boundary is, where the boundary ends within our safety zone, and where to stay normal to the part based off of that. I'll give you a couple examples here in a bit. But when I play this one that's completed, you can see the tool doesn't tilt away from the center of these holes. It's not changing, it's staying linearized from there. Now when it walks around, you can see I'm clearly not hitting anything. Then I'm adjusting to stay flat here the entirety of the time. So by changing a few of those options in there, those numbers, adding those projections, it knows to respect the motion of that boundary, but also the alignment to the part instead of the mesh itself. So if I change something like this guy here, my blending distance to 10 millimeters instead of 50 millimeters, you're going to see in this toolpath, I'm going to get a lot choppier of a motion. You can see how it's tilting away differently, and then going back in, and then tilting away, and then going back in, because it doesn't know to stay in line with this face here, because we have not passed that boundary that I told it to smooth across. Same thing goes here. Our mesh boundary is basically like this, so you're going to see the tool go this and then go this after coming out. Align there, revert back, and then align. So to help smooth that out, messing with these values and projections are going to help keep that going. And these max angle steps and linearization tolerance, ironically, when you're dealing with surface finishing in 5 axes, you want those to be really tight so that way you have a really good uniform finished surface. But when you're transferring from one section to another in a rapid, you really don't need to have that much linearization in the toolpath, so that way you're not, bogging down your machine just for a transition rapid motion. Oops, did I not turn on those vectors? There we go. Here we go. So you can see how these are they're not that tight. So that's, a lot easier code to work with just on a transition. If I tighten those numbers back up, those vectors, there's going to be so many more in line with that. So I say give me like a 1 thou. Oops. Linearization. And I up this degree here to like 1 degree. You see how many more vectors show up in that toolpath. It's not really necessary for a rapid transition from one spot to the next. So we can loosen that up. So while the safety zone itself is not a new enhancement, the options to really smooth it out is new in 2025. In our chamfer drill toolpath, the only new update in here is we've already had the surface feet per minute in here that maintain that surface footage, but now we have the maintain feet per tooth in here as well. So if I turn on this guy, it allows the maintain feet per tooth in there as well. So your feed rate and your RPMs will change the deeper the tool gets into that break edge that you're drilling into. So I was looking for a little bit of extra finesse in those toolpaths. That checkbox will help out. In Mastercam 2025, in previous versions, we used to have this issue with the OptiRough where the toolpath, whatever depth you assign to it, would start cutting from wherever you tell it to. And you'll get as many depths as you can, and eventually it'll start crunching up. You can see from here to here, this crunch here is different. That happens a lot of times because of the prescribed depth in there and the prescribed steep shallow variable that you put in there. In 2025, we now have the uniform step down checkbox. So this will automatically redo the step down amount you have put in there, and it'll make it even across the entirety of your part. So rather than crunching towards the bottom, it's going to start, that depth wherever it needs to maintain that section there. For those of you that have the multi-axis package, you've had the luxury of using the debird toolpath. Well, now in 2025, the debird toolpath is available in the 3D package as well, as an option. So, just a little bit of showing of what it does and how it behaves. It's nothing new to the 5-axis user. You would pick the machining geometry, which in this case is the part itself, what edges you want to cut, which I have all those pockets there, and what's the width of the cut you're trying to deal with. The only difference between this one and the 5-axis is on the tilting section, you only have 3-axis capability, whereas the other one would say 3, 4, 5. So the entirety of its menu is nothing different to the 5-axis user, except for the fact that you can't touch the 5-axis in there. So you can see with this little ball end mill that I have here, I have it contacting that section, walking up, nice and pretty, maintaining that even break edge along the entirety of that slope. When you're using the 2D chamfer toolpath, that slope, the steeper it gets, the harder that'll be on that section for that tool. So using the 3D deburr is going to be a lot more model aware of that edge and know exactly where to push away at. And right now I'm using a fast feed rate to get around rather than a rapid up and down, which can be easily changed to just rapid up and over, no problem. So that's the debird toolpath, and it'll utilize chamfer mills, ball nose end mills, I think bowl as well. There's a few different tools that you can utilize in there to get those breaks in there. Moving on to some unified toolpath functions. New in 2025, we have a new pattern available in here called the wireframe pattern. It doesn't utilize any surfaces, just wireframe or solid model edges. So you can see in here on this particular one, I have the solid edge right here. And I'm aligning my tool based off of this wireframe line that I drew on the screen. I told it to stay to the left of that line. I also told it in the tool axis control to be 45 degrees tilted from that section. So from this line, we've tilted over 45 degrees. So utilizing zero model selection for surfaces, I have achieved this toolpath here. This is very similar to using the old school curve toolpath, that curve 5 toolpath. You would pick a chain, you pick your tilt lines, and it will run around the way it would go. But the advantage of this with the unified is that you do have all of these other collision control capabilities. You have this new linking menu here that is more controllable than the curve 5 toolpath. So you do have all of those options in there. It's just another option you can work with, making all these tilt lines, utilizing those curves. Very similar to that curve 5, but with that extra finesse in there. Also in 2025, in previous versions, we would have the swarf toolpath on a tool like this, where you had this edge. You weren't able to use this edge here in the swarf. You had to use the entirety of this flute section here. And that could prove, a lot more tilting in there, engagement, all that fun stuff. Well, just like in 2024 release with the deburr option to use the flank or the tip, now this exists as well in the swarf. So I have flank or tip. So I just switch this over to tip, green check mark. It will now utilize the tip section. So if you have tools like this that you want to use one or the other, you can work with that. Does anyone have any questions on milling stuff? I'm going to move on to turning here if there are none, so I'll give it a couple seconds here. See if anything comes up. For those of you that have the mill turn environment, you know there's quite a lot of complicated processes you have to do in your programming, as well as setting up the simulation to run nice and smooth. So when setting up a turret, like so, you can see all the locators you had to put in there, the tools you had to put in there within the job, all this fun stuff, right? So, and including the projections. You can see this turret is loaded up nice and pretty. All the projections are where they want them to be. It's the custom tool that they want. Everything's set up in there. Now when it comes time to doing the next job, and you're dealing with this same job or a new job with the same setup. In 2024 and below, you'd have to go and deal with that whole setup all over again. As you can see in here, it's completely blank. Right? So any toolpath you make, you have to make the toolpaths, make the tools, put the locators in, load them in the right index. A lot of work to repeat from process to process and job to job. But if you have a good setup that you're always dealing with, in 2025 now, you can upload and save those configurations. This will also include your work holding. So if you had like a chuck jaw, a collet jaw, that kind of stuff, steady rest, anything within the configuration of the machine, all that information will load up. So if I hit this load machine configuration, I can load my job setup that I have saved already, which is from that other file that I showed you. In here, you're going to get the list of all the components, locators, chuck jaws, collet jaws, anything like that, collet chucks, that's going to be added into it. Anything in orange like this is showing you that you're replacing something that's already in the machine group, and that's fine. I want to replace it with whatever I had in this job setup anyways. So if I hit the green check mark, it's going to tell you, do you want to proceed? You're going to load up and replace stuff. Yes, okay. It's going to blink a couple times, and when I hit the green check mark and go to my setup over here for the turret, you can see all of the locators and tools are now loaded. This is a huge time saver, because when you're done programming, you don't have to worry about setting this up anymore. So if I go into the, let's say I want to run a face toolpath real quick, I have those tools already available. I don't even have to go look for them anymore. So that's nice when you have, you know, a machine that the tools never come out of it for any reason or another. You do need to have this configuration saved for the same machine type. So I can't just grab this, you know, if I'm running a DMG Mori and I want to try and put this on a Mazak, you know, I can't use the same configurations. Those machines are incompatible with each other in those options. So you have to go from the same machine group to the same machine group, old job to new job. Going back to this job right here, if you need to make an adjustment to anything in here, as far as moving the chuck jaw around, let's say we need to change the stick out to be a different amount. Something that was never exactly, put right in your face about the group in here, this pick-off cutoff group, is that you needed to replace it anytime you messed with the motion of these chuck jaws. So if I went into this job setup in here, and I changed the stick out in here from, let's say, 134, let's just say I change it to 140. In 2025, you're going to get this warning that's going to show you the turning stock boundary has changed, the automated part handling needs to be deleted. You can choose to keep it or delete it. But if you kept it, there's not really, it's not updated, and those stick out amounts and gripping amounts are going to be different. So if I say yes to delete it, I can regenerate these operations. And I can eventually go back into this area and add my pick-off cutoff to refresh it. I'm just going to go ahead and hit the green check mark. That's fine. So now my updated chuck jaw gripping is different. So that warning is something that wasn't, put right in front of your face in previous versions, and a lot of times it tripped people up with the pick-off cutoff routines. Moving on to some B-axis turning enhancements, and then we'll get into our Y-axis turning and A-axis as well. You can see in this B-axis turning toolpath, the tool just kind of stays engaged like so. We're not worried about the stock in here, but you can see the motion of this, how it's engaging, at this angle, and it doesn't really move from that spot. We can always set up our tilt lines, we can set up automatic, all that fun stuff as far as following that surface. But new in 2025, we have this tool angle control to either use a leading or trailing edge of this tool. So the normalcy of this curve right here, we can always tell it to stay at a particular angle. So let's say I do 70 degrees and hit the green check mark. When I run through it, this is staying upright at that 70 degrees here, and then as it's going down, you see it follows that 70-degree angle on that curve. We obviously are going to get a crash here, so that would be fun to deal with. Aside from all the other stuff we've had in the past, like working with the manual and modified functions, this controlling edge here will help alleviate the pressure here from wrecking into that section. So that trailing or leading edge angle is going to be useful. Moving on to A-axis and Y-axis turning. Some of you might not know what that really is, so I'm just going to go ahead and show a quick little video here of how this works. So I'll explain as it's cutting here. So these Y-axis parting tools, as you can see, instead of going straight down in X, it's using the Y going upward. That allows the cutting force to be pushed into the blade, into the turret, rather than flexing down on the blade as it's cutting. This allows for a quicker parting process. And this is useful within a turret machine or a B-axis machine. So any kind of mill turn environment that is available, you can do this work with. So that's Y-axis parting. Versus Y-axis turning, this one you do need a B-axis head that can rotate around in the A-axis to work with as well. So the way this works, with Y-axis turning, you're turning off the center from Y to cut into there. That allows all the cutting forces to go up into the head rather than push away from the side. Usually you're turning from up here. So you can see here, this is just grooving in there. But you also have the capability to use the A-axis to get into these tight places to finish. So they're going to use the same tool here. You see how that's rotating in there, in that tight area. So the nice thing about these A-axis and Y-axis tools is that you have a slimmer profile that can fit in multiple areas, potentially leading down to the ability of not needing as many tools to do a job in there. Now, how does that work inside of Mastercam 2025? Well, it's actually really easy to deal with. If I've got a toolpath like this, dynamic roughing here, right? You could see here's my tool doing all that motion. Most of your Y-axis turning options don't need any change within the toolpath. It all has to do with the tool you're picking. So when you're making these tools, you're designating them as Y-axis tools here. And that automatically converts the toolpath to work with that information. You also have to decide what angle you're pivoting this around. So like this lathe finish right here, you can see I have it twisted right here, so that way I can get into these areas without having any issues of running into my part. Whereas A-axis contour is exactly the same options of the B-axis contour, except you're utilizing that A-axis. So you can see here the tool wraps around, and that's moving simultaneously. So that's the difference between A-axis and Y-axis. One is stationary while the other spins around. And just like I mentioned before, with a cutoff tool, you're using the exact same cutoff toolpath. There's no difference whatsoever in here, except for the fact that you're picking the Y-axis tool. So it will automatically convert that information into the Y motion. So in simulation, when we run this, there's going to be times where you'll have to mess with a few different retract values. You can retract an X, Y, or Z now. You can approach an X, Y, and Z now because of that fact that you're, shifting over in that Y. Just going to put this over here. Go ahead and play this. Actually, I'll step a little bit forward. So you can see my tool comes over here, moves over and starts cutting. Flips around, cuts that area. Now it's going to switch tools. Slow this down. You can see that pivot there. And then when we get to the parting, you can see it's shifted over in Y. So that way it can cut off. And there we go. So that entire part was done using just Y and A-axis toolpaths. So a slimmer profile for your tools. You can utilize one tool to do the entire job for the most part. That concludes the rollout information here for our turning, milling, and design features for Mastercam 2025. these are all the greatest hits for this particular version. But if you ever need to reference and re-reference this information, you can always go to the Start menu of your computer, go into the Mastercam 2025 folder, and click on the What's New icon here. This is going to give you an interactive menu that you can mess with these options to get more information, or you can simply download it, view as PDF. And it will give you pretty much everything that we talked about here today. That concludes my presentation. I'm going to go ahead and pass it over to 2.0 over here, or maybe Matt Sump. I don't know who's going to talk first, and then we'll go from there.
Matt will take it.
Yeah, does anyone have any questions before I pass this over?
So I'll kind of make this brief. I just want to touch on our new product here called Cam Assist. I know Matt talked a little bit about it, and I'm going to kind of give more of a demo. So just if people weren't able to hear the first part of that, Cam Assist is an AI assist tool. So basically it's going to guarantee up to 50%, but it usually gets you about 80% of your part programmed. Now this really does require minimal setup, very little training, and it's tied directly to your CAM package. So the whole process, like I said, it's an assist tool. We're trying to gear more towards maybe helping newer programmers or trying to find a way to program your parts if you're not really too familiar with how the user interface of Mastercam works. It contains instant cycle time estimation and instant feed and speed optimization. It works with almost every CNC milling machine. Now it does not currently support lathes and mill turns, but that is in development. So those are just a few topics I wanted to address just right out of the gate. But let's go ahead and jump in and kind of take a look at how this Cam Assist works here. So there's a few kind of prerequisites we need to look at before we can jump into the actual Cam Assist portion. And that is, the first thing is you want to align your part, make sure it is typically on your top plane. That's kind of what we teach here with our training classes, as most of you have seen. So what I've done here is I've aligned my part to my top plane. That's my operation 1. And then I've also created an operation 2 for the back side here, as you can see. So first thing, get your part orientated, create your 2 different planes or as many operations as you want to do. Second thing is, I'm going to jump over to my tool manager page here. You have to define your tools as assemblies. They cannot just be tools, as you can see here. So I've just gone and picked a few tools that I thought were good to machine this part. And then next, what you're going to see on the toolpath manager here is I've created 2 different machine groups. I'm going to have my operation 1 as machine group 1, and then my op 2 is machine group 2. So there's a few things we have to look in here as well. So that being, you have to define your master model for both of these setups. It has to look at this as the finished part. That's basically what the master model does, is it just looks at what is the finished part to check against other things such as fixturing or other things in your models. You also have to define stock. So what I've done is, when I set this up, I can see my length, width, and height. Now when you're setting up 2 different operations, they both have to match identical. So my machine group 1 stock and model, or master model, have to be the same. So as you see here, I defined the exact same stock amount. And that's basically it. So I've defined my planes, I set my tools up as what I want to use in my assemblies, and I've created my 2 different machine groups, set up my stock. Now I'm going to jump over to our Cam Assist tool here. So right off the bat, there's just 3 tabs. That's all Cam Assist is here. And my tool library is the one I just showed you, where I pulled that assembly file in. You can define your different stock material. So we'll just say we're using the aluminum here. Now in the machine group, this is where you can define your different planes. So my op 1 is my top. And for my op 2, or my machine group 2, I'm going to go ahead and define that as my op 2 plane. You do have select avoidances if you had any fixturing or parts you wanted to avoid. But I can move over to the next page here. So for tool use, again, it's using that same tool library, same stock. Now I didn't go ahead and input any of those feeds and speeds, so I'm just going to say use Cloud NC cutting parameters only. And here's where I can take a look at the tools in that library, and you can determine what you want to do with it. So let's say, for instance, this flat end mill, maybe I didn't want to finish or have wall finishing or helical boring. You just uncheck that, and it doesn't look at the model for any of those features. Now I'm going to go ahead and keep them on just for this example, but you can see it's as simple as just turning those off and on. In the next tab, the advanced, you have what you want to do with those different tool paths, and they do give you a very detailed explanation on what those do. So I'm going to keep them all on for now just so we can see how much that kind of machines are apart. I like to use the proceed with errors. That way you may need to input more data or kind of fix your lead-ins or depth of cut. So having that option on will allow you to kind of finish the program and see what you need to fix from there. For any of the roughing, I'm just going to leave 10th out for the stock values. And then you have the operations that are going to be created. So we're limited with the toolpaths CamAssist makes, but that is in development for more toolpaths later on. So I'll just keep it order by type, and then you can choose what you want your flats to be. So I'm going to use the 3D horizontal area. And then for finishing, I'll use waterline is typically the one I like to go with. And maybe for deburring, you have a ball mill or chamfer mill. So I'll just leave it as is. And then I'll go ahead and hit the green check. So CamAssist does take a little processing time, but you saw with very minimal effort and minimal clicks, I'm going to be basically just able to green check. Now I'm not going to sit here and wait for this to load. What I've done is actually have the finished part in another screen here, and we can take a look at kind of what CamAssist has done. So it's going to output your machine group 1 and machine group 2, and it does create these stock models after each operation. It starts with the first one, then it'll create your roughing, followed by your next stock model, some more roughing, or helical boring in that case, and then another stock model. So that's operation 1, and then I can look at my next group 2 here. So it's going to use that same stock model that it was referenced in operation 1, and it's going to start roughing out my part. So there's another stock model followed by the rest of these tool paths to create our next stock model here. Oh, and then it just jumped on me because it's creating the operations as you see there. So let me go back here. Followed by some more finishing and contouring. So let's take a look at how this looks in Verify. So there's my operation 1, and then my operation 2. So with very few clicks, you can see it's like Matt said, it's kind of taken out the avoidances or the machining selection or the containment boundaries that you might need as more experienced programmer, and maybe the newer programmers might not know how to go about that just yet. So with just those 3 tabs and a few clicks, we have our part here. Let's see the progress on this other one. So just to see here, we had 23 operations on this one over here. That's still currently loading. That looks like it can't scroll down right as the moment, but it is the same amount of tool paths as you see there. So while that's still going, I'll show you another example here. This was another file that I went and ran CamAssist with. And it was a little bit more of a detailed part. not too crazy, but again, I set up my planes, created my top in an operation 2. I set up my tool library, and I ran through Cam Assist. And you're seeing the operation 1 and 2 machine groups. So right there you can see it's definitely machined more than 50%, so it does do a very nice job of roughing and finishing that model. Now a few things here, you may be asking, well, you know, if I'm not an experienced programmer or haven't used this, how do I go about adjusting these parameters? Well, if you are an experienced programmer, you would just go back into these parameters and you would know how to adjust your cut depth and cut parameters. But for those that don't and are just using Cam Assist, if I right click on that tool, we have this new section here for Cut Parameters Explorer. That's just a little check there letting me know. And here's the prompt. Now that that toolpath is completed, you'll see this is for the other one I was running. 17 operations were created, 65 of 80 surfaces machined. So more than half of the part. And then I would just say OK, and then you'll see it's going to be regenerating for a little bit here on the side. So back in this part here, when I went to edit those parameters, first thing I'm going to want to do right off the bat, because these are in metric, is I'll switch this to imperial. And you get this menu that's kind of tied together. So for instance, let's say I wanted to adjust a certain width of cut, which is my step over. I could do this a number of ways, but just for kind of dramatic effect here, I'm going to say 0.1. And you're going to see when I hit enter, those menus are tied together and they adjust each of those: chip load, surface, feed per tooth, spindle power. So if I save that operation and then I just regenerate, or just that operation, I force regenerate it, see how my step over increased just with that change. Now the rest of the model is going to go dirty because it is tied together with stock models. But what you do have is a direct live update with this page. So let's say, for instance, maybe I really increase this a lot. You'll see this kind of menu increase. Same with the width of cut. And it shows you graphically, oh, that was too much, so I'll tone it back down. And it also shows you your engagement with your depth and your step over. So that's where I could kind of tone it back down, or maybe I could go the other way with it. So you have different ways to adjust with this kind of live menu here. So that's just a little bit about the Cam Assist.
If there aren't any further questions, then we're going to go ahead and end the webinar. And yeah, I think I was muted there, but if anyone wants more info on Cam Assist, just reach out to our sales at ShopWare Inc. email, and Joel will get back to you.